In this lesson, I'll show you how to integrate trigonometric functions containing even powers. This is question number 1. The function they want us to integrate is sine squared x between 0 and a half. To integrate this function, we need to use an identity of sine squared x, which is shown right here. Sine squared x is equal to half times 1 minus cosine 2x. So let's go ahead and change sine squared x into the following. And by doing that, it makes it easier to integrate. So we have the integral between 0 and half for 1 over 2 times 1 minus cosine 2x dx. The first thing that I'll do is pull out this 1 over 2 outside of the integral. And this gives me 1 over 2 times the integral between 0 and half, 1 minus cosine 2x dx. The next step is to integrate each of these terms individually. So we'll integrate 1 individually between 0 and a half, and integrate negative cosine 2x also individually, where we have 1 over 2, and we'll introduce square brackets, because whatever we get within these square brackets, we multiply by half at the very end. We have the integral between 0 and 0.5, 1 over 2, of 1 dx, plus the integral between the same bounds, negative cosine 2x dx, close bracket. The integral of 1 is very easy, and if we're doing it relative to x, the integral of 1 is simply x. And we have to find out what that is equal to at 0.5 and at 0, but we'll do that later. To find the integral of negative cosine 2x is not hard, but we will need to use a u substitution. In fact, I'll show my work over here. What I'll do is substitute u in for 2x, and at the same time, pull out this negative. So let's do this part first. U is equal to 2x, and I'll take the derivative implicitly with respect to x. We end up with du over 2, I use the power rule, dx. Solving for dx is easy. Dx is equal to du over 2. And the reason why I'm doing this is so that I can substitute dx with du over 2. After pulling out this negative, I have minus the integral between 0 and 0.5 cosine, and remember we set 2x equal to u, and dx becomes du over 2. We haven't integrated yet. All we've done is a u substitution. Next, I'll pull out this half. Doesn't need to be here. And I'll rewrite what I have. The integral of cosine u, I'll show over here, is actually equal to sine u plus c. So instead of cosine u, I'm going to use sine u plus c. And by doing that, I've integrated the function. And of course, I will replace u with what I set it as originally, which was 2x. Here's what I mean by all that. 1 over 2 square bracket x between 0 and 0.5 minus 1 over 2, and this part has become sine 2x, and there's no need for a plus c because we have to evaluate this part now between 0 and 0.5. Now you'll notice that these two terms need to be evaluated at the same upper and lower bound. So instead of writing it out as 2, we'll just write it out as one expression. Now that we've done that, I'm going to use my calculator to evaluate this. Make sure that your calculator's in radians, as shown. We'll substitute 0.5 into x, and this x, and then multiply by half. 0.5 minus 0.5 times sine 2 times half is equal to 1. So sine 1. We end up with the following. Now substituting 0 into here, we get 0, and substituting 0 into here gives us sine 0, which is 0. So we don't need to go through the calculation. We have 0.0792 times half, or divided by 2, gives us 0.039. 0.039. Now interestingly, I do have an integration function on my calculator, so I can check this without having done any of this. Clicking this button, I write sine my variable x squared between 0 and 0.5, and I should get what I got below, and I do. And so there you have it. That is how to integrate trigonometric functions containing even powers. Make sure to watch question 2 for some more challenging examples.